problem creates a problem for us because do we only have multiplication and division going on? No. We have also subtraction and addition. So we cannot just easily simplify this as we did with the last problem. So what we'd have to do is we have to look into seeing, can I rewrite them as products? Right now I have a monomial, a rational monomial times a rational monomial. But each one of these terms are separated by addition or subtraction. So we can't do this simplifying like we did over here. We can only do that when we have terms that are multiplied by each other. These terms are not multiplied by each other, are they? No. So the process of writing an expression as a product is called, rhymes with tractoring. Factoring. That's why we factor to write an expression or a number as a product. OK? So can we rewrite x minus 5 as a product, though? Can we factor that out? Yes. So what can you factor out of x minus 5? Nothing. So we'll just leave it like that, right? OK. What about its denominator? Can I factor something out of 10x minus 2? What can you factor out that they share? Right? So remember, guys, all I did is I rewrote this now as a multiplication problem. So therefore, 2 times 5x is 10x, and 2 times negative 1 is negative 2. I didn't change the problem. I just rewrote it as a product. OK, Chris, is there a problem? No, you're good? OK. So now let's go and look at the next one. Can I factor 25x squared minus 1? All right. And yes, that is a difference of two squares. I know you guys haven't had as much experience with difference of two squares. But remember, is this a squared term, 25? Yes. Is x squared a squared term? Yes. Is 1 a squared term? Yes. Because 1 times 1, right? So yes, since you have all squared terms and you're subtracting them, you can rewrite this as 5x minus 1 times 5x plus 1. All right. And then my denominator, I need to see, can I factor that? All right. So that's a trinomial. We've practiced a lot of those. And you can see, yeah, that's a perfect square trinomial, which is x minus 5 times x minus 5. And I'm going to rewrite it out. Instead of writing x minus 5 squared, I'm going to write it out. Because now, I know you'd bring the argument, Ms. McLogan, there's still addition and subtraction. And you're right, there is. However, each addition and subtraction is now contained within the terms. You can see my parentheses. Each term, yes, has addition and subtraction in it. However, the terms are now multiplied by each other. In my original problem, the terms were not. They were added or subtracted to each other. Now what I've done is I've rewritten each term as a product. So now I can simplify these by dividing them out to 1 if they need to. So I have a 5x minus 1. That divides with 5x minus 1. I have an x minus 5. That divides with an x minus 5. So therefore, I'm just left then now with a 5x plus 1 over a 2 times x minus 5. And these do not simplify out, so that's your final answer. And you can put parentheses around that one if you want, but you're not, don't have to. OK? Katie, good for that one? Good. Any questions on that? So ladies and gentlemen, that's all I wanted to go over for you today.